In the previous video, we discussed about force, the effects of force, SI units of force, and the types of force. We classified force as balanced and unbalanced force, contact and non-contact force from lesson number 2, force and pressure. Can you name this cartoon character, children? Yes, you're right. It is Patrick Star from SpongeBob SquarePants. As we discuss the types of force, now identify the type of force involved here. Why is Patrick Star slipping when he steps a banana peel? See this ball. See, children? Can you see this ball? Yes. This ball is in motion, and after a while, it gets automatically stopped by itself. What is the reason why the ball is getting stopped by itself? The answer for all this is a contact force acting on these objects called as friction. So, what is friction? Why Patrick Star falls down due to the lack of friction between his feet and banana peel? Why the ball automatically comes to a halt? Because of the frictional force acting on the ball. So, what is friction? Frictional force or friction arises when two or more bodies in contact move or tend to move relative to each other. Friction acts always in the opposite direction of the moving body. Here you see, children, there is a box which is moving in one direction, that is towards your right side. And what is the force which is opposing its motion? It is friction, which always acts in a direction opposite to the direction of the moving object. And here you see a man who is trying to pull a trolley. This is moving towards your left side, and here the force of friction is opposite to the direction of motion. So this force of friction is acting towards your right hand side. Got it, children? Friction, why is it produced? Friction is produced due to the geometrical dissimilarities of the surface of the bodies which are in relative motion. Here you can see the wooden box placed on the floor. The irregularities on the surface of the box and the floor is not seen by our naked eyes, but even for a small geometrical dissimilarity, there will be an opposing force acting against the direction of force. So, we can know that this friction is caused due to geometrical dissimilarities between the surfaces that are in contact. Now, let us see this with the help of a microscopic model of friction. Here you see the box is trying to move on the rough surface, and the rough surface in turn is providing a force against its motion, and that is called as friction. Okay, children, now let us see the effects of friction, what all friction can do. The first effect of friction is it opposes motion. So, how does it oppose motion? Look here, children, there is a box kept on the floor. This box wants to move in this direction, that is towards your right. But it's very difficult for us to move this box. Why? Because there is a force acting against its motion, and that is called as friction. Friction is a force that acts in an opposite direction to movement. So, what is friction? Friction can oppose the motion of an object. Okay, so this friction, when you say that it is opposing the motion, it exactly reduces the speed of a moving object. Okay, children. Next, you see friction causes wear and tear of the surfaces in contact. What do you mean by wear and tear? Wear and tear means damage which is caused by normal usage. So here when we see this wear and tear is caused by friction, here are the best examples in front of you. You can see the sole of a slipper and the tire of a bus which are damaged as a result of normal wear. This happens due to the frictional force acting on the ground. that is the force of friction acting between the rough surface, that is the sole of the slipper, and the ground. And in case of a tire, it is the grooved tire, the friction between the grooved tires and the floor. Here, friction acts and it causes wear and tear, damaged on continuous usage. Okay, children. Next, you see friction produces heat. Friction produces heat. When you rub your hands, one hand goes in one direction. When you rub your hand, one hand goes in one direction and the other goes in the opposite direction, and the other goes in the opposite direction. We can assume that one hand goes in the opposite direction of the other, and friction come into existence here, and your palm becomes warm. This shows that friction produces heat. People, those who are living in Kodaikanal, Ooty during the winter season, often they rub their hands with each other. Why? So that they can keep their body temperature little warmer. Okay, so people living in cold places, they can keep their body warm. They can keep their hands warm by rubbing their palms against each other. As we have seen the effects of friction, now let us look at the factors that affect friction. So here, the first factor that affects friction is the nature of surface. Nature of surface means the surfaces that are in contact with each other. Here, now you just see, we are going to perform an activity to study how the nature of surface in contact affects frictional force. Okay, so now we are going to have an activity in front of you. We are going to take a pile of notebooks. What we are going to take? A pile of notebooks. Then a wooden plank. Next is a pencil cell, two pencil cells or any cylindrical object. And then we are going to take a table. And then we are going to set up an arrangement like this above the table. We'll have a pile of notebooks, we'll make the wooden plank as an inclined plane, and then we'll allow the pencil cell to roll over it. After that, we'll measure the distance covered by the pencil cell, and if suppose it is around 12 centimeter, suppose it is 12 centimeter, the next arrangement is we will spread a paper above the table, and then again we'll allow the pencil cells to roll on it, and when it rolls we'll see that the distance covered by it is around 8 centimeter. Suppose it has 8 centimeter. Okay, and then next what we do is we'll spread a turkey towel above the table, and then the same way we'll allow the pencil cells to roll on it, and then we'll measure the distance. After you measure the distance, it is found to be 5 centimeter. Now out of all these situations, which surface the pencil cell was able to move the maximum and it was able to move the minimum? It was able to move the maximum in the plain wooden table, which was covered by a sun mica layer, and it was able to cover the minimum distance when it was allowed to move on the cloth. Okay, so now I try to answer my questions. In which case is the distance covered the minimum? It was a minimum in case of the towel spread on the table. Why do you think it was minimum in that case? Because in that case only the surface of contact between the pencil cell and the cloth was very rough. Okay, so here we can say that both the object which is rolling or object which is moving, its surface and the surface on which it is rolling or moving matters, both matters. Okay, so here due to the roughness of the towel, the pencil cell could not cover much distance, because in this case the rough surface could offer more frictional force against the direction of motion of the pencil cell, so it offered more friction. Why is the distance covered by the pencil cell different every time? Because of the difference in the nature of the surface. More the roughness of the surface, more will be the friction. Okay, children. So here we can say that this distance covered depends on the nature of the surface on which the cell moves. Okay. Could the smoothness of the surface of the cell affect the distance traveled by it? Yes, it also could affect the distance traveled by it, because all the three cases the same pencil cell was used, and all the three times whatever pencil cell was used, it had a very smooth surface. Okay, so if the surface of the pencil cell would have been very rough, then the distance moved by it would be even lesser than the distance moved by the pencil cell now. So what do we conclude by this? We conclude that more rough the surface is, more friction is produced, and more smooth the surface is, less friction is produced. So rough surfaces offer more friction, and smooth surface offers less friction. The next factor that affects the friction is weight of the body. Let us try to understand with the help of this activity. Here you see a man who is trying to push 100 Newton box. You all know here 100 Newton refers to the weight of the box. It weighs 100 Newton. Okay. Now you see children, here when he is trying to push it, whether the box is able to move. No, it is not able to move. Why is it not able to move? Because it has more weight, and here the frictional force offered by the surfaces in contact is greater than the muscular force applied. And why this frictional force is greater? Due to the more weight of the object. But in the second case, you see here the same man is trying to push the 100 Newton box, and he is able to easily push it. Why is he able to easily push it? Because here the frictional force is less than the muscular force. That is, whatever force he is applying, it is able to move the box, because the frictional force which is acting against the direction of motion is lesser than the force applied by the man. So here why is it less? Because the weight of the object is only 100 Newton. So less the weight, what do we conclude from this? Less the weight, less is the frictional force offered. It is just with this example I can explain you children. When you go for cycling, okay, when you go in singles, you are able to easily ride the bicycle. But sometimes your friend may ask you to give him a lift. And when he is giving a lift, what happens? You will have to carry him in your carrier. So your weight along with his weight will get added up. At that time, will it be easy for you to move this with the same speed? No. Why? Because more the weight, more is the force of friction offered. So your speed will get reduced. So why is your speed getting reduced? Because as we have already discussed that friction opposes the motion of an object. So more the friction, more will be the opposing force. So you cannot ride the cycle as fast as you're riding here. So what do we conclude from this children? Greater the weight, greater is the force of friction. Next is the area of contact. So let us see how area of contact affects the friction. Area of contact, with the help of this example, can you visualize what is this? A road roller. Now you see the cycle. Can you compare the tires of both? Road roller is having a very broad tire, but cycle is having a very narrow tire. Now you see the motion of this road roller. Road roller is moving very slowly, but this cycle is moving very fast. So, why is it that the cycle is able to move very fast and the road roller is not able to move very fast? Because the tire of the road roller is very broad. Area of contact is very high. More the area of contact, more will be the friction offered. Okay. And less the area of contact, less will be the friction offered. So, greater the area of contact, greater is the force of friction. Got it, children? Next, you see, we have to discuss about the different types of friction. We should know that friction not only occurs on the surfaces, solid surfaces in contact, it also exists between the liquids and gases that are in contact with the solid objects. So here you should know that friction is classified as dry friction and fluid friction. What do you mean by dry friction? Dry friction is classified as static friction and dynamic friction. Okay, but what is dry friction? You should know what is dry friction. Dry friction is the force that opposes the motion of one solid surface across another solid surface. As you know, liquids and gases have the ability to flow, and that is why they are called as fluids. There is a friction whenever an object moves through a fluid also, which is called as fluid friction, or fluid friction is also called as drag. What is fluid friction also called as? Drag. So, as I said, dry friction is classified as static friction and dynamic friction. What do you mean by static friction? Let us study one by one. One by one, let us go through each type of friction. So, first is the static friction. You can see the box which is placed on the right hand side. Here, towards your right hand side, there is a box placed. Okay, it is called a static. Why it is called a static? Because the two surfaces are not in motion relative to each other while the two bodies are touching each other. You may think that the box which is there on the left hand side also is not in motion, but I'll tell you when it will move. I'll make it move, you see. Okay, so you should know that static friction is the friction experienced when individuals try to move a stationary object on a surface without actually triggering any relative motion between the body and the surface in contact. Okay, so static friction acts when the objects are at rest, when the two objects which are in contact with each other are at rest. Now you see this case, that is here when the box in the left hand side is sliding. It was, you saw it moving. So what is this friction offered called as? It is called as either kinetic friction or dynamic friction. Why is it called as kinetic friction? Because the two surfaces are in motion relative to each other. Okay, just now you saw that these were in relative motion to each other. Okay, can you see this? The motion of the box on the surface. Okay, and this type of friction is nothing but the force that acts between moving surfaces in contact with each other. Okay, kinetic friction is further classified as sliding friction and rolling friction. You should know that static friction is always greater than kinetic friction. So what is greater than kinetic friction? Static friction is greater than kinetic friction. So you can also say that static friction is greater than sliding friction and rolling friction. Now let us just have a look at the kinetic friction, and then let us go on to the sliding friction, children. Here you see the box is sliding over the surface to and fro. It is just moving from left to right, then again from right to left. The friction created by two objects sliding against each other is called as sliding friction. And you all know, since kinetic friction is less than static friction, sliding friction also will be less than static friction. Next comes the rolling friction. Okay, so what do you see here? Just see this type of friction here shown is the rolling friction. Now you can see the person. What was he doing? What was he doing? He is rolling his trolley fitted with wheels. So, see the magnified image of the wheels fitted in it. So this friction created when one body rolls on the surface of another body, we see that rolling friction is less than sliding friction. Let us perform an activity to show that rolling friction is less than sliding friction. Since it is very easy to roll your trolley bag rather than sliding it, but we have to prove it. So how to prove that rolling friction is less than sliding friction? Place a box on the table and hook it with the spring balance. Try to slide it. Okay, and then note the readings of the spring balance. It is showing around 800 in magnitude. Now arrange the color pencils on the table and place the box over it, and hook it with the spring balance and try to pull it. When you pull, this time again you note down the reading. It is showing between 300 to 400. What do you understand in the second case? The second case, the force which was needed for pulling the box was less, but in the first case it was more. So what does this mean? That while rolling, the opposing force which was opposing the motion of the box was less, and in the first case the opposing force which was opposing the motion of the box was more. So by this itself we can say that rolling friction is less than sliding friction. Got it, children? So we can say that friction not only exists between the two solid surface that is in contact with each other, but it also exists between a solid and a liquid. Okay, that is solid and a fluid, we can say either the solid and liquid or solid and gases. Okay, and this friction which exists between a solid and a fluid is called as drag or fluid friction. Now see a ship moving in water, and then now you can see the aeroplane moving in the air. Ship experience friction due to water and aeroplane experience friction due to air. So they are provided with streamlined body. Sometimes they may ask you a question, why the ships and aeroplanes are provided with streamlined body? To reduce the drag or fluid friction. So let us come to a conclusion that now, till now, what all we discussed about what is friction. Friction is the force which acts always in a direction opposite to the direction of motion of an object. The effects of friction. Friction opposes motion, friction produces heat, and we also know that friction causes wear and tear. The factors affecting friction. What are the factors affecting friction? Nature of surface. Rough surface offers more friction, smooth surface offers less friction. The weight of the object. More the weight, more is the friction produced. Less is the weight, less the friction produced. And then third factor is area of contact. More the area of contact, more will be the friction offered. Less the area of contact, less will be the friction offered. And we also discussed about different types of friction. And which is the least among all the different types of friction acting between two solid surfaces in contact? That is rolling friction. Rolling friction is less than sliding friction, and sliding friction is less than static friction. And the friction between a solid and a fluid is called as fluid friction or drag. So let us end this topic, children, with great pleasure. I thank you. I'm so happy for you people to cooperate with me and listen to my class with great patience. Thank you all. அந்த ஒரு இடத்துல